Welcome to The Explainer. Today we're going to completely shatter the grand illusion of artificial intelligence. It's so easy to look at human-like text or these stunning AI images and just assume there's a conscious mind at work in there. But we're looking way past the interface today. We're going to explore exactly how we force this messy, continuous, probabilistic math into rigid, deterministic tile semantics using the command line interface, the CLI, and the absolute mathematical purity of cellular automata.
Because we're covering a lot of ground today, here's our mental map. We'll hit the grand computational illusion, look at the tokenization bottleneck, cross the semiotic bridge, dive into non-halting math, check out the Chopsticks architecture, and finally wrap up with the human orchestrator.
All right, let's just jump right into Section 1, the grand computational illusion.
So I want to start off with a question that might honestly break how you view your devices. When you ask an AI a really complex question, does it actually understand the meaning of your words? We intuitively feel like the machine gets it, right? Because the output makes sense to us. But the crazy reality is, the machine doesn't understand your intent at all, not even a little bit. It literally only understands pure physics, resistance, and voltage. To understand why, we have to look at the stark contrast between two very different parts of a computer's physical brain. On one side, you have the floating point unit, or the FPU. Think of this guy as the gambler. When it hits complex math for AI, it essentially throws darts at a dartboard to approximate the answer using these secret proprietary seed tables burned right into the silicon. Sure, it's incredibly fast, but it's a lossy guessing game. On the flip side, we have the arithmetic logic unit, the ALU. This is our surveyor. The surveyor deals strictly in 100% exact, universally deterministic hardware truths. 1 plus 1 is exactly 2, every single time, on every single machine on Earth. And right now, most AI relies almost entirely on that gambler, which becomes a massive issue when we need absolute, undeniable accuracy.
So what happens when we try to force our fuzzy thoughts into that system? Let's move to Section 2, the tokenization bottleneck.
Deep inside an AI, concepts exist in what's called a continuous vector space. It's this fuzzy, flowing map of meaning where ideas blend together, kind of like our own human associative thought. But here's the catch. Digital computers can't handle smooth, continuous concepts. The machine actually has to violently chop that continuous meaning into discrete, rigid ASCII text chunks, a process we call subword tokenization, just to process it. It's a massive, violent clash between the fluid meaning the AI maps out and the discrete symbols the hardware actually reads.
And this leads to a huge problem. When that fuzzy AI logic relies on the FPU gambler to process data, it acts like a giant blender, creating a total non-deterministic nightmare. The original identity and exact provenance of your data, totally destroyed. Think about it. You know what went into the blender, but you absolutely cannot reverse engineer that smoothie back into the exact fruits it came from. That loss of exact provenance is exactly why modern deep learning struggles so much with strict rule-based execution. So how do we fix this? That brings us to Section 3, text as the semiotic bridge.
You see, text isn't just for reading anymore. It is the operational literature of machines. It acts as our semiotic bridge. Specifically, the CLI is this mathematically pure, well-ordered matrix. It really echoes Donald Knuth's principles of deterministic control, acting as the universal interface that safely compiles our messy, associative human imagination directly into pure, unadulterated hardware execution. When we use explicit text scripts like JSON or Python in the CLI, we completely bypass the fuzzy guessing of the gambler and we mandate absolute precision.
Look at this comparison. On one side, we have human symbolic cognition, what researchers call OS alpha. It's nonlinear, intuitive, warm. On the other side, we have ALU execution, cold, rigid, discrete mechanical silicon logic gates. Modern deep learning code, stuff like PyTorch and Helion, essentially exists to force that continuous probabilistic math into these rigid deterministic tile semantics for perfect ALU fidelity. We are, quite literally, tricking cold rocks into thinking with lightning.
Let's step into Section 4 and look at the geometry making this possible, the math of non-halting systems.
There's a magic number here, exactly 1/3. This scale parameter is actually derived from Pythagorean triples, like your classic 3-4-5 triangle. And it turns out, this is the secret to unlocking continuous digital flow. Advanced architecture relies on this simple, beautiful ratio to perfectly execute the tiling semantics required to bridge continuous math into discrete logic.
By relying on Conway's cellular automata, we can treat state changes as continuous, beautifully zooming geometric transitions rather than halted, isolated computations. This guarantees perfect structural tiling. Imagine an endlessly zooming animation of nested rectangles. Because it relies on infinite, non-repeating geometric sequences, the system literally never reaches a terminal state. It completely dodges those fatal stack overflows, allowing recursive calculations to run safely and indefinitely.
Now, how do developers actually use this? Let's check out Section 5, the Chopsticks architecture.
When trying to enforce digital rules, traditional developers usually built these heavy, monolithic smart contracts. Honestly, it's like building a $1 million hyper-complex robotic arm just to pick up a single piece of sushi. The Chopsticks architecture, like the X42 protocol, bypasses all that legacy bloat. It uses a beautifully straightforward chopsticks-tiled matrix approach. It's an elegant, lightweight webhook design, basically two simple sticks getting the exact same job done perfectly.
It's a really simple three-part client callback loop. Step 1. The server demands cryptographic proof with an HTTP 402 payment required message. Step 2. The client wallet signs that proof. And Step 3. It retries to instantly unlock the resource. This event-driven loop creates a total immutable lock-in. It literally forces probabilistic AI to yield to strict ALU fidelity in real time, bridging the gap between digital ledger data and physical reality without any massive chaotic intermediaries.
Finally, let's bring it all back to you in Section 6, the human orchestrator.
AI cannot cleanly sever its interconnected vector data on its own. The ultimate resolution here is that the human pilot must actively prune the code. We have to apply our manual sweat of the brow to act as the steward over the machine's automated miasma. It's your active, declarative text that forces the machine to behave predictably and with absolute fidelity.
We're transitioning from being solitary creators to becoming human orchestrators, managing the rigid, mathematical execution of the machine through text. So, as these AI systems grow more powerful and their interfaces become more invisible, will you actively use text to wield the divine script and enforce deterministic fidelity? Or will you just let the probabilistic noise take control? Think about it. If we stop riding the bridge, who controls the physics? Thank you for joining me on this explainer. Keep learning and always look past the screen.